Hi everyone, this is Moraga, Johannes Malwati. Today I'm going to be taking you through the igneous textures. And we know, as geologists, we tend to classify the igneous rocks in terms of their mode of formation, their colors, their textures, and even their composition. So the one of the classification of the igneous rocks is their mode of formation, or the mode of formation of igneous rocks. So the mode of formation, that is to say, we're talking the intrusive and the extrusive. So the extrusive, it's when the magma erupts out of the Earth's surface and then experiencing the atmospheric temperatures, and then that atmospheric temperatures, they will make the magma to cool faster. So the extrusive rocks, they are characterized by fine textures wherein the crystals are too small to be seen with our naked eyes, and they need to be seen using what we call a microscope. So the crystals had less time to form, or the magma cooled faster, giving the crystal less time to form. That is the extrusive rocks. So most of the extrusive rocks, such as the rhyolite, the andesite, the basalt, and komatiite, they have this texture, or texture that is fine grained, wherein the magma during its formation, it was exposed to different magmatic or different or atmospheric temperatures. We know one of the classification, this is extrusive, this is intrusive. So I have something that will make you remember these rocks that I was talking about, the extrusive rocks. So we use what we call rep K, then GDGP. These rocks over here, they are ultramafic rocks. This, it means komatiite, and then this means peridotite. These are the mafic rocks. This means basalt, this means gabbro, and then these are the intermediate rocks. This means andesite, this means diorite. Then these are the felsic rock. This R means rhyolite, and this G means granite. This is to help you not to forget most of the igneous rocks that we see in this universe of ours. So when we're talking the intrusive, that is to say the rocks such as granite, diorite, gabbro, and peridotite, these rocks, they are characterized by coarse grains that can be seen with our naked eyes. And then that is to say the magma cooled within the earth crust, wherein the magma cooled within the earth crust, and the crystals had enough time to crystallize, since they are not exposed to atmospheric temperatures that affected the magma during its solidification. So the extrusive and the extrusive is the mode of formation of different igneous rocks. So the textures, one of the textures, famous textures, is the glassy textures. Glassy texture in igneous petrology. So the glassy texture, you can look at this rock, we call it an obsidian. Look closely into this rock, you can see that there is no minerals, or there is no grains that are seen within this rock. So we call it non-crystalline. We call it non-crystalline. Non-crystalline. That is to say, this rock, it shows no crystals at all. So the glassy texture is a texture that is non-crystalline, wherein the rock contains no crystals at all. It resulted from cooling that was faster, that denied the minerals to have chance to crystallize. So the glassy texture is well seen in the obsidian. Going further, we talking the aphanitic texture. So this texture is a kind of a texture wherein it is mostly seen in extrusive rocks, wherein the magma had little time to crystallize, and then the crystals that can be formed will be small crystals that they need the usage of the microscope to be well seen. So that is to say, with our naked eyes, the aphanitic texture can't be seen with our naked eyes. Look at this diagram over here at your far right. You can see that within the box there is no crystals that can be seen. But obviously, when we say there's no crystals, they are not like the one that we visited previously, the obsidian, wherein the crystals had no chance at all to crystallize. Here, the crystals they formed, but they didn't have enough time to grow. Hence, we only see grayish background, kind of like if you were to draw this. Obviously, this is to show you that there is no crystals that can be seen with our naked eyes. They need the usage of the microscope. So this rock, it's what we call a rhyolite, showing the aphanitic texture. If you can look closely into this rock, you can see that there is no visible grains that obviously you can identify and say, okay, this is the mineral quartz, this is the mineral feldspar. You will struggle to see that with your naked eye. So this is aphanitic texture, displayed mostly on the extrusive rocks. Even the andesite and the komatiite and the basalt can have this texture, wherein you cannot see the crystals with your naked eyes. But looking at the rock granite over here, you can see different minerals, the quartz, the K feldspars. You can see different minerals that are shown in the rock. That is to say, you can identify each mineral that this rock comprises of. So, in a nutshell, a phaneritic texture is a type of texture that require no microscope to be seen. That is to say, the kind of texture wherein the crystals can be seen with our naked eyes. And then obviously this texture, it is seen in most of the intrusive rocks, the granite, the diorite, gabbro, and even the peridotites and other related intrusive rocks. This texture, phaneritic texture, can be seen in such rocks. Look at this diagram again. Now you can see the different textures within this box. So these different textures, or this texture, phaneritic, it is the texture that can be seen with our naked eye. So if you can see the crystals with your naked eye, know that you are talking phaneritic texture, and it is mostly seen in the intrusive rocks. But other texture, such as a porphyritic texture, well seen in the rock porphyritic basalt. The porphyritic texture, it is rather the type of a texture wherein it is characterized by two stages of cooling. That is to say, slow cooling to grow few crystals, or slow cooling to grow large crystals. And then obviously the second stage will be followed by the rapid cooling, grow many smaller crystals. So remember the textures in igneous petrology, or the textures, the major fundamental process, or the factor that determines the texture in igneous rocks, is the cooling rate. That is to say, whether the rate of cooling was faster or was slow. And then do not forget that the textures, they reveal so much about how the rock has been formed, and they reveal so much about the origin of different igneous rocks. So if we know for a fact that the textures reveal so much about the formation or the initial processes that could have occurred during the formation of such a rock, then we would understand that when we look at this rock, we start to see the larger crystals. In igneous petrology, these larger crystals are called phenocryst, depicted on the diagram on your far left. So these are the phenocryst, the larger crystals, and then the smaller crystals, such as these ones, they are called the ground mass. The ground mass is like the aphanitic, that they are usually not, or usually you cannot be able to identify them with your naked eyes. So do not forget that these porphyritic textures, I said it experienced two stages of cooling: slow cooling to grow few large crystals, then they are followed by the rapid cooling to grow many smaller crystals. Then that in itself, it will result in what we call a porphyritic texture. So this texture, you can see that it has two or more distinct size of grains. The sizes of grains, they are not the same, they are distinct, they are different. So even the single stage cooling can also produce this porphyritic texture. Or in a simple terms, you can also see that this porphyritic texture is a mixture of aphanitic and phaneritic, in a simple term. So this texture is well seen in porphyritic basalt, but do not forget that it was formed by mainly two stages of cooling: slow cooling, after slow cooling that gave the crystals enough time to grow, and then after that slow cooling, that faster cooling, that made or gave the crystal less time to grow. And then let's talk the pyroclastic texture. Do not forget that if the magma has a high gas content and high viscosity, the gas will expand in an explosive manner, or in an explosive fashion. But before we can talk about this pyroclastic texture, then even the vesicular texture, I wanna take you quickly through this. Remember, you should understand what a magma is. Magma, it can be defined as a mixture of the gas, the mixture of obviously the crystals, and even the liquid. So should you understand that the magma is the mixture of the three? And obviously the gas, we know that the major gases we know of the H2O and even the carbon dioxide. But sometimes we have minor textures such as chlorine, fluorine, etc. These are the minor gases, and then the major gases are the H2O and carbon dioxide. So if I were to draw this diagram, like the diagram you've seen before, the Aphanitic. So assume that within the box there is a magma. That is to say, the mixture of the gas, the mixture of gas, the mixture of crystals, and the mixture of the liquid. But the main reason why you can identify each of the three parameters is mainly because the three, they are in a solution. They are in a solution. You can identify or you can pick each of these parameters, that is to say gas, crystals, and the liquid. The three, they are in a solution. Now let's say the magma now was going or was going up from the mantle, was erupting, that is to say. Now before the magma could reach the surface, when it the magma goes up, the gases, they get to experience more pressure. And then one thing that I realized about the gases is that they don't like pressure. They don't like pressure. When they experience more pressure, they will tend to get out of the solution. Now you start to see the bubbles. You'll start to see the bubbles. This is because the main reason why they get out of the solution is because they can't tolerate the pressure. So, which is why you start to see these crystals or these gases getting out of the solution in the form of bubbles. Like, for instance, I used to give people an example that if you can have a cold drink, a fizzy drink, and then agitate that, you'll see different gases that they wanna get out of that bottle. Should you open the bottle, obviously the cold drink with enough violent gases, because now you've agitated them, you've increased the pressure, they will erupt, or the cold drink will get out violently. So this is the case. Now if we formed these bubbles, and then during eruption the gases will be forced out of this, and then when they forced out, they will leave what we call holes, or they will leave what we call vesicles. Now vesicles, they are holes that were left by the escaping of the gas. So if these holes, they get to be filled with the secondary minerals such as quartz and obviously some calcium, the calcium, the calcite, and other secondary minerals, then we start to talk about the rock amygdale, and the texture, it will be called amygdaloidal. The texture, it will be amygdaloidal. But the only holes, only these empty spaces that usually are found within the rocks, then the texture, it will be called the vesicular texture. So I was still on this vesicular texture. Vesicular texture, it is well seen in the rocks, pumice, and even the scoria. But let's first understand the pyroclastic materials. So I was telling you that if the magma has a high gas content and a high viscosity, the gas will expand in an explosive fashion, like I told you, and break the liquid, obviously, into clots that fly through the air and cool along their path through the atmosphere. That is to say, when the magma erupts, along the way, along the way, it will cool in the atmosphere, and then obviously, or or alternatively, it can blast out the solid pieces of rocks that once formed the volcanic rocks. So all of these fragments are referred to as pyroclast. And then we know for a fact that pyroclast is the hot broken fragments. Remember, pyro it means heat, and then clast, obviously the broken fragments. So which is why I'm saying the pyroclast is the hot broken fragments. And then sometimes we have a loose assemblages called tephra. Tephra is the loose assemblages or the loose materials. So, or if you don't want to say loose assemblages, you can say unconsolidated materials. They are called tephras. They are not consolidated. And then pyroclast, hot broken fragments. So, depending on the size, the tephra can be classified as blocks, lapilli, or the ash. This was just basic on different pyroclastic rocks. So you can now have what we call pyroclastic rocks. When there is a welding, the compaction, and the deposition of other grains called loose material, called tephra. Now, this is to say if or to have a pyroclastic rocks, there should be welding, compaction, and deposition of other grains that will cause the loose material, the tephra, or the unconsolidated materials to form or to finally form a pyroclastic rock. So a pyroclastic rock is a kind of a rock that was formed when the unconsolidated materials called tephra, they underwent welding, compaction, and deposition. This was to explain you how the kind of the pyroclastic material or the kind of pyroclastic rocks get to be formed. Now look at different grain sizes. We have the different types of the grain sizes, and then within this rock you can see this pyroclastic texture, wherein if you were to move your hand through this rock, you'll feel different sizes. This was a pyroclastic texture. Then the vesicular texture. This is the type of a texture wherein, as like I've explained, as magma erupted, the gas, due to the pressure they experience, they will get out of the solution, and then in the form of bubbles, and they will bubble out, leaving these holes, and then these are called the vesicles. This is the type of a texture well seen in the pumice and even the scoria. And then obviously the rock, it is characterized by less density. Why less density? Because as just imagine, the magma had the mixture of the gas, the crystals, and even the liquid, and then one of the mixture, that is to say gas, get out of that solution. Obviously it will make the rock to be less dense, which is why the pumice is less dense. It can float on top of the water, it cannot sink because it is less dense. This is the vesicular texture. But like I said, that if these vesicles, if these holes were to be filled with the secondary minerals such as quartz, then the texture, it will now be called the amygdaloidal. It will be called amygdaloidal. Sometimes this vesicular texture, it is well seen in what we call a vesicular basalt. You see that the basalt has got many holes, but if those holes were to be filled with the minerals, then it will be called amygdaloidal basalt. You can go check into that, the vesicular or the amygdaloidal basalt. So now we've been talking much about the textures, and then I told you that the main driver or the main factor that determines the texture of an igneous rock is the cooling rate. And then I've also explained to you that the cooling rate or the textures, they reveal so much about the processes, the initial processes that could have formed the igneous rock. So before we can talk much about this diagram, we should at first understand what we call a nucleation. We should understand what a nucleation is. So a nucleation is an initial process that occurs in the formation of a crystal from a solution or from a liquid or from a magma. Then nucleation can also occur in crystal solution to grow new crystals. So this is the initial process of a formation of what? Of crystals. This is to explain to you that imagine this nucleation as formation of a nucleus. Obviously, different life forms in our universe, they were derived from the nucleus. If we had no nucleus, obviously there wouldn't be any growth. So we should, according to my own understanding or according to my own perspective of things, you should have a nucleus, and then that nucleus will make certain life forms to either grow. So we should have a nucleus. And then after nucleation, we will have a growth. So nucleation, like I said, is an initial process of formation of crystals. And so like this statement at the top, it's saying the growth and the nucleation rates are the function of the degree of undercooling. We will see shortly what that simply means. So strong undercooling, it will equal to the nucleation, that it will be greater than the growth, and then we will have fine texture. Then moderate undercooling, then it will result in the growth that is greater than nucleation, then coarse grained. But do not get to be confused by this. I will show you in the diagram, and then you will be able to unpack this nucleation in your or on your own. So look at the temperature TA, TB, and TC. If we were to draw the line here, we can see that the line TC doesn't intersect the nucleation. This simply means the nucleation or the initial process didn't occur. The initial process of formation of nucleus didn't occur. So if the initial process of formation of nucleus didn't occur, obviously there won't be any growth, like I said. Or if there is no nucleus creation, there will be no nucleation, and obviously there won't be any growth. So remember the textures we've explained, that if the crystals had no chance to form, we have what we call a glassy texture. So the question here is saying, what are the rocks and the textures at TA, TB, and TC respectively? So I want to start with the TC, temperature TC. So like I said, that the crystals at TC, they had no time to crystallize. Looking at the line, the red line that I've just drawn, there is no intersection of the nucleation. And look at even the growth curve, it is far away to be intersected by the TC, which is why now we can talk of a glassy texture. glassy texture. And then, like we mentioned before, the rock, it will be obsidian. The rock, it will be obsidian. But now, if we were again to draw the line from TB, you can see that, okay, the line is well drawn. You can see that from the far top, the TB intersected the nucleation first and at high rate. This is to say, at TB, the nucleation rate was so high, the initial process of formation of crystals was too high. So, because this is an initial process and it is so high, but look at the intersection of the red line, or the red line on the growth curve. Now you can see that the growth curve, it is intersected at lower or at the far bottom. So we can say that even though we have the nucleation rate that is high, but the growth is so small, the growth is not enough. And we know, and we've explained before, that if the crystals had no or they had little time to grow, we will talk of the aphanitic texture. Aphanitic texture, because the crystals, look at the growth, the crystals didn't grow much, but the growth is there, but they didn't grow much, even though the nucleation is intersected at the higher rate. Then the type of rocks, we've explained that we can choose a basalt, we can choose a komatiite, we can choose the rhyolite or andesite. That is well seen in what we call Rep K. And then now let's look at the temperature T at the temperature TA. Draw the line again. Now look at that from the far top. The TA, the line TA intersected the growth at the higher rate. But the nucleation here, it wasn't that high. So the nucleation rate, or the initial process of formation of crystal, it was low. But we know that this is the formation, like we can say, the formation of the nucleus. If we formed the nucleus, obviously there is a high chance that the growth will be there. Now we formed the crystals here, but at the low rate. But the growth of those crystals is so high. Then if the growth of the crystal is so high, obviously we will start to see the coarse grained, that is well displayed by the intrusive rocks such as granite, diorite, gabbro, and even the peridotite. And then we know that now we're talking of a phaneritic texture. Phaneritic texture. Phaneritic texture in TA. And then rock, you can choose the gabbro, you can choose the diorite, you can choose even the granite. You can choose even the granite, and you've seen previously that the granite has crystals that can be well seen with our naked eyes. So look at the phaneritic texture that we already explained. The crystals can be seen with our naked eyes. So this is exactly what is happening in igneous petrology when we're talking the textures. Don't forget to like, to subscribe, so that and even to have a comment below, so that, remember, if you are subscribing, you give us the chance to produce, or you give us the allowance to produce more videos. So subscribe, like, and comment, so that when we produce other videos, you get to be the first to be notified, and then so that we make the geology or the understanding of the geologic concepts to be easy. Thank you, guys.